So we added to the agenda a tech talk from AVL, and we can say basically we have been developing software not really like software. It has been also in our industry traditionally quite hardware-centric driven. That's why it was our idea to give you our view in terms of how we can transform this hardware-centric development. One key aspect is, of course, not only the software, but consider also the relationship that this has with system engineering. And for this reason, we asked Wolfgang Puntigam and Peter Ebner from AVL to just tell us their opinion. So welcome on stage. Thank you, Sarah.
Thank you.
Riportiamo.
Sì. And the second one. And it takes you switch slides. I'm gonna sit here.
Okay, thank you. Hello, also from my side. Thank you for the possibility to present here our view on software-defined vehicles. Okay. Oops. Okay. I think all of you have maybe a car or drive with modern cars. The expectation of the customers change on vehicles. Yeah? We all have the experience with our mobile phones, and we expect a similar experience on also our cars. Yeah? It's not expected or it's not accepted anymore that cars, yeah, you buy it and 10 years it takes the same software, there is no upgrade possibility and so on. I think it's also a lot in the newspaper about this, and all of you are aware the value creation, the part of the software which is in a car is growing very, very fast. Also, that means the value coming from software is increasing and will increase even more. Nevertheless, what is the key message from our side? A software-defined vehicle, even if the software defines the function, the attributes, is still a vehicle. The customer buys a car, so that means this integration of the software into the car, the experience of the customer with the car is even defined by the overall system consisting of hardware and software. What is the base where we are coming from? Yeah? If you look here, you see roughly a development approach which is used or which was used for a vehicle development. Yeah? We have concept phases where we define the functions, where we define the hardware. Then simulations are executed. The suppliers or even the OEM start with the development of the component. We have defined software cycles in previous times, 6, 7, maybe 8 software cycles. This is then integrated. And then we have somewhere the start of production, and 10 years the same product is produced. What are the issues with this? Yeah? If we increase now the number of software functionality itself, we see that this development of this functionality driven by software is insufficient. Yeah? We have only a very limited time to test our software. Yeah, so the result is not a robust application. We also have low depths of software testing. We expect or we see that there are late changes on the software, and this has then a problem on the testing topic again. Yeah? And which is even more critical, it's getting more and more difficult to reproduce software bugs on a test bed, and therefore we need a new solution. So what are the drivers for the development? Yeah? I think all of you are involved in this, so that means we get less money for the development. We have to increase the complexity of the system. We have to be faster on the market. And we have to develop more variants for the products. So in principle, a lot of target conflicts trade-offs which we have to meet. Yeah? Looking on the numbers which are coming from the market, this ratio has significantly changed. The ratio between the base variant and the derivatives, which was between one base variant, two to four variants. And this is changed now for the battery electric vehicles up to a ratio of 1 to 10, respectively even higher. So that means an OEM is producing one hardware and setting up on this single hardware up to 10 or even more products which he sells. If we talk about complexity, the challenge of complexity, where does this complexity come from? Yeah, looking on a battery electric vehicle, I think it's obvious having a battery, having an e-motor is not that complex. The most complex vehicle which is on the market is a plug-in hybrid. Yeah? So he combines the complexity of a combustion, a vehicle driven by a combustion engine together with a vehicle, a pure electric vehicle. Yeah, we have on the one hand very complex functionality inside the vehicle itself, to ensure the compliance regarding emission legislation and so on. And we have the complexity to connect this vehicle also to the grid. So the exchange of energy on the one hand, all these communication protocols and so on. And for sure, all of these vehicles have the possibility or the capability for in-field software update, more common now for the new systems like plugins or battery electric vehicles. If you look about the change on the system complexity, what we see here is again hardware variants. Yeah? Hardware variant mean I start with a SOP, then maybe 4 years later I come with a new market variant which has similarity to the original one, and again 4 years later I come with the next variant. Looking on the software variant, it's even more complex. Yeah? So I could bring new software in a much higher frequency. This is the one topic. And the second one, this new software which is operated on an, let's say, already aged vehicle generates more or less an own variant. And for the OEM or of the producer, it's very important. He still has to follow reliability, safety, and security of the vehicle. Yeah? So this software update should not change anything. It must be compliant to all valid standards and also to legal boundaries. And this is the complexity where we have to deal with. And one example about this, yeah, so you see here more or less the same measurement result from one and the same hardware of a vehicle, and which uses 2 different software versions with 2 different calibration versions to be compliant for specific markets. Yeah? And you see here the main difference is if we run this vehicle on the same cycle, that the behavior is slightly different. Yeah? This is driven by the different legislations or the different demands from the market. Nevertheless, the development, the integration and the testing must be done also on this variant. So the key question now is, how does such a development environment look like to do such a development? Yeah, Wolfgang.
Thank you. Hello. Yeah, thank you, Peter. I will talk now a little bit what are now the demands or the challenges for the tool chains. And as Peter said, as we're talking here about software-defined vehicles, but there is still hardware. Right at the end, it's about the well integration of software and hardware. But we see major changes and challenges in the change of the methodologies which have to be applied within the vehicle development process, and also about the process itself. So this functional orientation becomes much more relevant through the whole development process. And also we have to rethink our validation and verification strategies. So what changes do we see? On the one hand side, we see really a transformation or a change in the focus. The whole automotive industry is coming out of this hardware-centric focus, hardware-centric development process, here represented by this V model. Of course, Software was always part of it, right? On the component level, on the vehicle level, distributed in all the different ECUs, what we are seeing today. So there's really a mind, and it's a change in the development focus, but also a mindset change necessary if we go, and we have to, and we will go more into this software-defined area. So the hardware is still there, but you can see the software also as a wrap around that, because we will see different speeds on the hardware side and on the software side. And the vehicle functionality will define to a very high extent only through software. What we also observe is we see also a paradigm shift then in the validation and verification process. Why? Because when we talk about software, it's the mandatory thing is that we are able to, or that we are enable a continuous validation against all these vehicle variants, as also Peter showed before. And you imagine if you do that in the traditional way, you will not find so much hardware available. That's why we have to mirror these hardware prototypes into what we call, into the virtual world, into virtual prototypes. So they have a virtual representation of the vehicle. And this is the basis, according to the DevOps cycle, to test against this virtual prototype and to get instant feedback on changes. So this is the first paradigm shift. The second paradigm shift in the validation process is when it comes to update over the air, you have to see you have a huge installed base of software with all the variants and different variant trees, as also Peter shown before. And the question is now, if you really would like to provide an update over the air, does that really work for your installed base, of software? That's why we see here also the necessity to have a virtual representation, a virtual prototype of these individual vehicles, which has to be tested, or the release candidates, what you intend to release, to then test against this virtual environment. Otherwise, there will be no chance with this complexity to deal within the field. So how do we see now the development ecosystem of the future? So as you see in that graph, you see on the bottom left side, that's a typical hardware-based approach, a lot of hardware-based testing. And you see now additionally what we see is mandatory to enhance it by a pure virtual approach. So of course you still start with defining your features, your functionality, but much more customer-centric at the beginning. And then you can go two paths in parallel. The one is the pure virtual path, which is more dedicated or closer connected to a typical DevOps cycle or development cycle out of the DevOps approach. And of course, the hardware will stay, but it will be enhanced by simulation to have really what we also call the combined virtual real prototype, because the key thing is to get immediately feedback on a system level. And now we have a third environment, and the third environment is really the in-vehicle, the fleet out there. And the key what we see is to now connect these different environments be fast for exchange data, and to have a high automation when it comes to test software. So, how we tackle now these challenges, and let me give you some concrete examples on that. First of all, if you really go in this direction of continuous validation, which is absolutely necessary when we talk about software development and software release, and coming to the picture what Peter showed before, where we are coming from, we see now three key elements what must be implemented within the development process. The first is to have a continuous integrations of systems engineering and software in the loop through the whole development process. That's the first key thing. The second key thing is the introduction of these virtual or combined virtual real prototypes. And the third key thing is to have also implement data analytics to really have access to the data out of these different environments, because this whole DevOps cycles lives from feedback. You need instant feedback, and you have to manage all the data which is coming out of that, because that will enable us then to really jump between the virtual and real environment in a kind of closed loop, which is mandatory if we talk about agile development and going away from a typical waterfall process. Therefore, we also, I would like to show now, we have developed out of that together with Microsoft what we call the DevOps pilot. The DevOps pilot has three key goals. The first goal is to provide a kind of collaboration platform, an open platform which brings different people, different developers together. So the simulation community together with the software community, with the testing community. The second goal is to have a high automation, because this whole process lives from high automation, to provide the third thing, immediately feedback on any changes on the software side. So we're coming here from the left side, so that it starts with managing the different things like simulation models or code itself, so the code variants, and also the test cases. And from this left side, we have then to combine these different artifacts, like the simulation models with the software versions together with the test cases, and we create a kind of parking lot of all these variants. And as you can imagine, that's a huge amount of variants when you think back on the paradigm shift what we are facing. And then after you have this parking lot on your, more or less on your build machine, then we have to be able to execute it automatically in a pure software in the loop environment and on the cloud or on premise, or also deploy it on a hardware in the loop environment, or do real testing environments in a very high automated format. So we see that as a key to bring these different people, different roles together, and to provide this high automation to get instant feedback out of it. And of course, key is also to have always the full traceability where you are. If you think about the huge amount of functional test cases which have to be applied on testing release candidates for updates over the air, that you see what tests are finished, where you see issues, where you have to go back, make a drill down, make changes in the code, or where you have some vulnerabilities. So let me summarize now a little bit what we see. So we as AVL, for us, it's important to understand the whole ecosystem, the whole chain from the product definition, from the requirements down to the development tool chain until the final release, and also what happens in the in-use phase. And because we really see that this model-based approach and the system engineering, the structured thinking, will be key to manage this complexity through the process. And therefore, we see it's absolutely necessary to provide open standards, open APIs, that we really collaboratively can work together between simulation, between test, between software developers. That's why we are dedicated also to, for example, to the CBO, to the code of PLM openness, which is driven out of the ProStep EVIP. But also that's why we are contributing and engaging in communities like that, because at the end we see we only can master these challenges if we work together and really coming here up with innovations together. Before I really finish, let me give you a last message. Whatever we do, whatever we invent, whatever on cool technology what we work, the key thing will be, if it's at the end of the day not a business case for the development departments or for the OEMs, it will not find their way or this way in their way in our daily life, which is absolutely necessary. You see here a summary out of a lot of projects what we have done, where we can show already value in terms of by introducing this software in the continuous software in the loop environments, or providing methodologies like this DevOps pilot, that we really on the one hand side can really reduce real prototypes, of course by increasing virtual prototypes, so there is an investment, and by really significant reduce time, reduce costs, but in the same time to increase the test coverage. Thank you very much for your attention.
Yeah, so thanks a lot for the nice introduction and for setting up the stage around the SDV. Any question from the audience? Question. Don't be shy. Yes, Kai. Please do be nice.
Yeah, thank you for your presentation. I was wondering if you are involved in any of the projects in the SDV working groups already. Maybe the OpenDUT project, which comes to my mind when I see what you have been talking about. Awesome. Okay, thank you.
Any other question? Ah, sorry. He's closer.
You mentioned that the complexity is going to increase in the software area. Usually when complexity increases, the error rates increase as well. How do you tackle that? Are you afraid of rising error rates in the field, or are there new processes in place? At the end, it's very important to have as few as possible errors in the field, and growing complexity is really, a development against this. So how do you tackle that?
Yeah, thank you for the question. It's one of the key problems. Yes. What we find is that having a good description of the system based on, for example, systems engineering, helps you to structurize your system and to tailor them down where could be sources of errors. This is one thing that we, let's say, using methods like FMEAs, risk assessments, and so on to identify potential root causes of errors. And the second one is to increase this test coverage by also the virtual world, and in combination with analytics. Because our virtual vehicles, we are able to configure in a way that we, let's say, increase already here the models of the hardware. Yeah? We could introduce here old hardware, or we could introduce tolerances coming from production and so on into our virtual models to ensure that the product which is then driving on the road at the customer hand has a minimum number of failures. On the other hand, and this is part of the software, is also diagnostics. This means we introduce functions which are able to identify failures in course of operation, and which then on the one hand protects for sure the user, but also protects the vehicle and gives the feedback to the OEM that there is something not working as intended. So these are measures which we introduce usually.
Maybe also from a different angle out of our tool development. Test automation, right? So when I look back where we are coming from 10 years ago or so, or 15 years ago, where there is a lot of tests were manually written and also manually executed. Today, so the key is really to have a full automated process to have to increase the test coverage to. It's not always possible to 100%, but of course to a very high extent. What we're also using today, in addition to use LLM methodologies, that we using this out of the requirements documents, that additionally to our software developers to get also support out of LLM methodologies to also increase the test cases. And then it's key to react very fast, because no software, as we know, is bug-free. It's always a feature, maybe not by intention.
Hello. So my name is Lucas Macha. I'm from the University of Bath in the UK. It was a really good presentation. I enjoyed the technological challenges you tackling. I was just wondering, actually 2 questions. So first of all, if you were transforming the automotive industry into this software-defined vehicle era, what are the people challenges associated with, so like telling people that the hardware is not the main interest anymore, it's through software definition, and through the software is what's defining the attributes and the functions on the vehicle. Do you see that sort of being problematic going forward with how things has been done in the past?
It's also, how should I say, there are many challenges about that, right? And of course, we're coming out of this hardware-centric work, but it's not only, it's also a mindset and a cultural change, because the unit under test is really the software. So what we are doing to overcome the challenges is really to combine mixture teams, so teams which are coming traditionally out of a hardware development approach, because this knowledge is still important, right? It's not going away. So to really combine, to build form teams out of this traditional hardware-centric approach together with our software teams. And what we really see, that's not easy, because they're also speaking different languages at the beginning. They're really talking different languages. Also, this to understand what does it mean to build up a DevOps pipeline, to have everything automated as high as possible. So that's one bit, to bring these experiences from these different worlds together, because we also see that this massive change where we are, or our industry is, you cannot hire 2,000, 3,000 only software developers, right? There is also a kind of education what is needed to educate people. We also, from our own experience, for example, we are engaging in communities like that, also to bring in new people that they can learn. Also, we're partnering with companies like Microsoft to bring in here also knowledge. But to really make it happen, I think that's really, how should I say, I think we can read everybody every day in the newspaper. It's not done. So that will last, of course, also a couple of time to make that happen.
It's brilliant, thank you. And can I have one more question?
Yeah.
So I think the test coverage has come up a few times, and I think traditionally has been the case of we want to achieve the highest test coverage possible to show that there's no bugs in the system. How do we know from software testing principles that exhaustive testing is impossible? Especially the more functions you have, the more you haven't got all the time in the world and all the money in the world to do testing exhaustively. Have you thought about different approaches to testing? Maybe trying to find the defects instead of trying to prove there are no defects, like driving the system to failure instead of proving that the system works in all cases. Like, is there any shift in the mindset that would be sort of along those lines?
Yeah, there are methods in development to go exactly in this direction. So I think also here on the methodology side, that the possibilities which we get here with virtual testing gets strong increasing, and every method which helps us to increase efficiency to make the product more mature is for sure helpful, and we are open to introduce this. But exactly what you mentioned, to prove not that the product is working, but to find the areas where it's not working. That's one of the areas where we are working on.
And the question is always about how big is the increment, the feature increment. You go from one release to the next, right? It could be also that to have more releases with smaller increments, to reduce the failure rates or the issues what you get back then from the productive system. But it's always a discussion with the project, right? Because they always would like to go for big feature, big feature steps.
Thank you.
So we maybe have time for one last question. Maybe there is one from the audience online. Should be in the slide. Oh.
There is one question. Is it possible to reduce the brightness of the big screen?
What do you answer?
I hope so.
Okay. Yeah. Any further question? Well, again, thanks a lot for being here. Thanks a lot for this introduction.